It challenged many of the popular perceptions of environmental doom and catastrophe that have become the common wisdom of our time. Leading science journals in Britain and the US commissioned reviews which were often scathing and hostile. Lomborg's critique of environmental doom and his heretical thoughts on global warming were roundly condemned. This film attempts to explain Bjorn Lomborg's ideas.
A very good reason why people have reacted to it so strongly is because for many, over the last 10 to 15 years, the ideas of the environment have become a religion, and a very ancient religion.
I think what was unfortunate was that he combined what was his opinions and what were his very valid questions with facts that then turned out not always to be correct, or what he was presenting as facts, which didn't always turn out to be exactly as he was portraying them to be.
He was saying things that a lot of people didn't like, that the problems with the environment were rather different from what everybody else had been saying. And it is true that he's not a specialist in this field, and he just come in from the outside, but I think that's enormously to his credit.
I'm a Dane. 1,000 years ago, one of my countrymen, the famous King Canute, sat on an English beach and tried to hold back the waves. He couldn't do it, of course. Legend has it that he was trying to persuade his court of flatterers that no man, no king even, could command nature. Only God could do that. In the end, he had to be carried away from the consuming tide. Today, we're faced with a far more threatening demonstration of the power of the sea, and God may not come to the rescue. It's not the tide we have to contend with, it's our fear that the tide will keep coming and coming, that global warming will cause sea levels to rise until we drown in our human arrogance. But rising sea levels are only part of a bigger picture of catastrophe. Violent storms, hurricanes and floods, melting ice caps, changing sea currents, parts of the earth becoming waterlogged, other parts becoming desert, uninhabitable and unusable by man. Of the more moderate estimates, some studies suggest that sea levels will rise by less than a foot in the next 100 years. But others say it'll rise by much more than that, by 3 feet, pretty devastating for the millions of people who live around low-lying coastal areas. This is not because it's predicted that the Antarctic will melt. All models show that won't happen in the next 100 years. But with warmer temperatures, the oceans, like everything else, will expand.
Global warming is the darkest shadow in the environmental debate, but it's not the only one. Along with it is a litany of anxieties widely understood as the common wisdom of our time.
That man is killing the earth with pollution, chemicals and waste, that he has plundered resources to exhaustion, that he is destroying forests and with them the plants and animals that live there. That there are just too many people consuming too many of the world's resources to go on like this much longer. One way or the other, the litany goes, we're headed for a fall.
But I don't think so. I want to take you back to the evidence. I want to tell you why many things are better than we think they are. That doesn't mean that there are no problems, but it does mean that instead of panicking, we can focus on making rational choices about the remaining real problems that confront us.
I got involved in this whole debate by accident. It wasn't meant to happen. It was in a bookshop 5 years ago in Los Angeles that I came across an article that made me angry, by an academic, Julian Simon, arguing that much of the familiar doomsaying of the environment lobby and media is not true. I was furious. I'm a Scandinavian vegetarian, a lefty academic, and a former member of Greenpeace.
I took the article back to my best students in Denmark. Together, we're going to prove him wrong. The problem is, we couldn't. In the last few years, I found that much of the litany of the green movement just doesn't fit the facts. It's not that they lie, but they often only tell us part of the story. When business organizations tell us not to worry about the environment, they may be right, but they certainly also have an interest. We need to realize that likewise when environmental organizations tell us that everything is going to hell, they might have a point, but they equally have an interest.
When my book outlining this thesis and calling into question plans to combat global warming was published last year, I was attacked by many in the environmental movement. I can certainly understand why. I would have felt the same 5 years ago. But my argument is based simply on data from all the most trusted sources on Earth: the United Nations, the European Union, the OECD, the World Bank. Unlike some in the so-called skeptical camp, I do not dispute that global warming is happening, and yes, man's technology is contributing to the heating of the planet by increasing the amount of carbon dioxide in the air. Where I disagree with my critics is on what to do about global warming at this point, and I seriously question whether the Kyoto Agreement to limit carbon dioxide emissions of the developed countries is the best way to try to help those who will be most directly affected by global warming, which is the developing world.
The first thing I discovered when I began investigating the doom scenarios was that quite often there was another side to these stories, which few people know about and few journalists bother to report. Bad news sells, after all, and generates money for research and campaigns. Nobody owns the weather, and nobody complains if you frighten them about the climate the way they would if you raised unjustified hopes or fears about, say, a cure for cancer or a miraculous heart treatment.
For years, we've been barraged by bad news about the environment. The ferocity of the 1997-98 El Niño was, we were told, yet another sign of global warming.
The inferno brought on by the effect of El Niño.
El Niño is being blamed for this and the lack of rain further south in Colombia. Farmers there are desperate for rain. Such is the diverse impact of El Niño.
It was blamed for wrecking tourism, causing allergies, melting ski slopes, causing 22 deaths by dumping snow in Ohio. The financial cost for the US alone was estimated at $4 billion. But a recent report from the American Meteorological Society suggests that for the US, the benefits of El Niño far outweighed the costs. The positives included higher winter temperatures, so fewer deaths from coal and reduced fuel costs. There were fewer spring floods caused by snow melt because there was less snow. And El Niño was followed, in a well-known pattern, by a period of relative calm in the Atlantic. There were no big hurricanes to hit Florida in 1998. The AMS estimates the financial benefits of El Niño at $19 billion, almost 5 times its cost. Where was that reported? The Exxon Valdez was the biggest oil spill ever to hit the US. 266,000 barrels of oil slipped into Prince William Sound, Alaska. TV pictures showed oil-laden birds, blackened seal pups, aerials of slick, the shoreline covered in black slime. There was an outrage over a presumed ecological disaster. The cost of compensation for Exxon was $3.5 billion. A huge cleanup was ordered. But 250,000 dead birds is 1 day's toll from birds flying into plate glass in the US, or 2 days' kill from domestic cats in Britain. The oil spilled was equivalent to 2 days' oil deposited by powerboats off US shores. As to the long-term consequences, the individual species and ecology of the Sound has been restored or is recovering. There has not been an ecological collapse. And the cleanup probably did more harm than good. A section of beach left deliberately uncleaned recovered much faster. And the trend in oil disasters? There are far fewer oil slicks in the world now than there were 30 years ago, and oil will eventually evaporate, degrade, or form relatively harmless lumps of tar. Where did you hear or read that?
The other major environmental alarm of the last 15 years was raised by scientists from the British Antarctic Survey based here in Cambridge. That alarm was about the hole in the ozone layer.
No one expected the first evidence of damage to the ozone layer to appear over the Antarctic. Scientists had known of the potential damage CFCs could do since the mid-1970s, but it was more than 10 years before the British Antarctic team found an ozone hole in the unlikeliest of places.
It was naturally expected that you would see ozone depletion close to the release of the chlorofluorocarbons, which is in the populated industrial countries of Europe and North America and Japan. So we were looking in the Antarctic just in case. And of course we didn't find any evidence of ozone depletion in the 1970s because nothing had happened in the Antarctic that would seriously deplete ozone. That didn't happen until the early 1980s.
The ozone layer had also thinned by 6% over the populated parts of the globe. There were fears about skin cancers, cataracts, and wrinkles. True, skin cancer has increased, but that's almost entirely because of the sunbathing craze of recent decades. In fact, the 6% thinning of the ozone layer is equivalent to moving just 125 miles closer to the equator. The closer you get, the more your exposure to harmful sunlight. It was the same effect as moving from Manchester to London or Albany to New York.
The ozone question, the Antarctic ozone hole depletion, was a relatively easy problem to solve, you might say in retrospect, because it affected only a small corner of one industry, the chemicals industry. And in fact, it was possible for them to convert to other chemicals and go on making money out of those alternative chemicals.
Most significant, the action taken to ban CFCs means that the United Nations predicts the ozone layer will recover over the next 50 years. Did you know that? Who reported it? The spirit of environmental catastrophe dates back decades. Rachel Carson's Silent Spring, 1962, first predicted a planet poisoned by man-made chemicals. Since then, the doomsayers have regularly predicted a fall. The celebrated Stanford professor, Paul Ehrlich, author of The Population Bomb, predicted in 1970 that mass starvation would reduce the population of the US to 26 million by the year 2000, 1/10 of its actual size. He also expected that the surviving average American would eat less than is enjoyed today by the average African. There were texts warning that man's reckless disregard for nature was killing off species at the rate of 40,000 per year. But in fact, we have not more starvation in the world now, but less, and the number of species being lost is a fraction of that predicted.
The confusing part of green alarmism is that it comes at us from every which angle with very different, sometimes opposing consequences. On the one hand, we're told the burning of fossil fuels is heating up the planet, threatening climate disaster. But we've also, for the longest time, been warned that we are rapidly running out of energy and that this will end civilization as we know it anyway.
In fact, fears of an oil crisis are almost a century old. In 1914, the US Bureau of Mines estimated there were 10 years of consumption left. In 1939, an estimate from US Interior Ministry, 13 years reserves. A 1951 estimate, again 13 years. In 1972, the limits to growth showed that the world would be dry of oil by 1992. In fact, today known oil reserves are higher than they have ever been. This is for several reasons. For a start, known reserves are not fixed. They depend on who is looking where, and exploration is expensive, so it's done as need dictates. Our extraction techniques have improved enormously, and there's been a doubling of energy efficiency in the last 30 years. Reserves of gas too, the cleanest of the common fossil fuels, have also increased since 1973. The supply of coal is enormous, though it is polluting. And fossil fuels, once thought too expensive, methane, tar sands and shale oil, are becoming ever more economic. The issue is not whether we have enough, it's how do we extract it, refine it, store it, transport it and use it.
We aren't running out of most raw materials either. As with oil, the reserves of the most important raw materials to our industrial production have risen and their prices have fallen over the last 150 years. Aluminium, iron, copper, zinc, most minerals. Like oil, reserves of these materials only become known and measured when they are looked for. We may use up the easily accessible iron ore, but at the same time, we produce technology that will enable our kids and grandkids to get less accessible iron out, even cheaper, leaving them with more, not less.
And we're much more sparing in how we use resources. The average car built today uses just half the carbon steel of a car built in 1970. And we buy fewer things. In times of old, we would buy real stuff, but increasingly most of what we buy is information, computer programs, games and DVDs, with minimal physical content. We recycle much more, and we can substitute one material for another if it becomes rare or too expensive.
Everybody knows that we produce too much waste, don't they? In the US, for example, each person produces 4.5 pounds of trash a day, which has doubled since 1966. But actually, the volume of waste that ends up in landfill sites has stopped increasing because we incinerate more, we recycle more, and we even compost trash.
The most extreme example is the US. If its population doubles in the next 100 years, the landfill needed to take all that waste would be a square 18 miles on each side and 100 feet tall. That's approximately the size of a quarter of Woodward County, Oklahoma, 1/12,000th of the total area of the US. Here in the UK, the waste of the next 100 years would require a square 8 miles on each side and 100 feet tall. That's 28% of the area of the Isle of Man, which isn't a suggestion.
Many people think that as we grow more prosperous, we pollute our atmosphere more and more. But in fact, London, which has the longest records in the world, has cleaner air today than it has had since the late 16th century.
King Edward I established the world's first pollution commission in 1285. Later he issued a decree that no one should burn coal in the city. One unfortunate Londoner was executed for breaching the order. The Industrial Revolution really accelerated the emission of damaging smoke particles, lead, sulfur, nitrogen oxides and carbon monoxide, the pollutants that most damage human health. But since around 1900, smoke and sulfur pollution began declining steadily. Since the Second World War, we've seen a decline in all the important pollutants. The last great smog in London in 1952 killed 4,000 people in 7 days. That partly motivated the Clean Air Acts, which followed, promoting less pollution. But the cleanup has been equally, if not more, driven by economics and changes in technology, substituting cleaner fuels, oil for coal, for example, and gas, which is even cleaner. Air quality monitoring in all major urban centers in the developed world confirms that we now have much cleaner air than we did 50 or 100 years ago. Despite their increasing numbers, today's cars use lead-free petrol, and less of it because engines are more efficient, and have catalytic converters to reduce noxious emissions. Air pollution is not a new problem getting worse. It's an old problem getting better. As we get richer, we get cleaner too. But so far, this is only true for the developed world. The most polluted places on Earth are the megacities of the Third World, now going through the dirty phase of industrialization. The problem is that green anxieties are a luxury good. We worry about them after we've filled our bellies and bought a fridge. The developing world may follow the West's pattern of industrialization, pollute first, clean up second. But since cleaner first world technology can now be bought, the developing world's transition should be cleaner than ours. Beijing is polluted, but not nearly as polluted as London was in 1900. The richest cities are beginning to clean up. Air quality in Santiago and Mexico City is improving, another underreported fact. There are many theories about why my countrymen first made the journey from Denmark to England. One is about climate change. It was warmer in the North Atlantic around the first millennium, which was why the Vikings could also get to Greenland. Possibly they could expand because they had a richer base. And others about food shortages. It suggested that the herring population in the North Sea fell drastically. Again, the Vikings came looking to fill their bellies. The point is that one lesson of human history is our ability to adapt to changing environments. Admittedly, the Vikings adapted by raping, pillaging, and plundering, but that was in a different moral climate too. Now the challenge of change and adaptation is upon us again. Our energy-hungry civilization and the burning of fossil fuels is affecting the climate. But I think we need to avoid taking action for its own sake, without carefully considering how effective it will be.
Today, our biggest environmental fear is of uncontrolled and uncontrollable climate change all across the world, forever affecting us all. How high will the sea rise? Will there be more storms and hurricanes, more floods and freak weather? Will much of Britain become a floodplain and much of Spain a desert? Or will the changes be slight and even beneficial to some parts of the world? What can we do about it? And what should we do about it?
The greenhouse gases, principally carbon dioxide and methane, are at the heart of every aspect of our developed industrialized societies. Every time we travel, we burn carbon dioxide. Whenever we cook, turn on a light, watch TV, buy any manufactured goods, clothes, furniture, food, we're contributing to pumping more and more CO2 into the atmosphere, because at each point usually a fossil fuel will have been burnt to extract, manufacture and transport it to us. Five years ago, a huge environmental conference was held at Kyoto, Japan, to try to agree an international plan to reduce the carbon emissions responsible for global warming.
Japan is playing host to more than 150 countries for what's being called the biggest ever environmental debate.
Climate change is one of the most serious global environmental issues that we have ever encountered.
Consensus was hard to find, But the nations of the developed world did finally agree to cut their carbon emissions in the early years of this century, and to cut them by 30% of what they would otherwise have been, allowing for economic growth. The developing world, however, was committed to no such reduction. In my view, not only is the plan a bad one, it won't make enough difference to justify its cost, but it is also based on science which is far from certain.
First, we have to know a little about how scientists are attempting to understand climate change over the ages, and how they're trying to predict changes in the future. And the first place to start is back here in Cambridge, at the British Antarctic Survey.
By studying samples of polar ice, scientists here can make the best assessment of global temperatures through the ages. They can also correlate carbon dioxide in the atmosphere with temperature and look ahead to some of the possible problems for the future.
The oldest ice we've got in here at the moment is, well, we don't have very much of it because this is from a very large European project to drill an ice core all the way through to the bedrock, 3,300 metres deep. But this is ice that fell during the last glacial period, so this is ice that's about 35,000 years old. As the snow falls through the atmosphere, it collects a lot of the chemistry that's in the atmosphere, and trapped within the grains of the ice there's some air pockets, and as the ice builds up year on year, as each subsequent snowfall compresses the deeper layers, then eventually these little pockets of air become trapped as bubbles, and these are actual samples of old atmospheres. If I just take a slice off the end.
By analysing both water from the ice and the trapped air bubbles, it's possible to calculate what the temperature was during different periods, and also know what the atmosphere was like, how much carbon dioxide was in the air, for example.
Take a piece of the ice and drop it into some warm water. You should see the gas. So you're looking at a real past atmosphere being released here. What I've plotted here is the carbon dioxide record taken from the air bubbles in the ice. And you can see that over the past 450,000 years, that not only has temperature gone up and down, but so has carbon dioxide. And in fact, it's gone up and down in a fairly similar cycle to the temperature. Here's 3 ice cores. Compared it to a meteorological record, you can see that it shows a slight increase in temperature over the last 50 years. Well, we can go back much further in time with our ice cores, and you can see that the ice cores also, this one in particular, shows if you started from 50 years ago, does show a slight warming, so does this one. But taken over time, you can see this recent warming in the ice core record. There seems to be only part of a longer-term natural cycle within the ice.
Scientists from the British Antarctic Survey are also monitoring the one possibility that makes everyone nervous, that the polar ice caps might break up and dissolve into the ocean, potentially raising sea levels by meters around the world.
This map is a map of the height of the bedrock beneath the Antarctic ice sheet. The area that's giving rise to concern is this area that's resting on rock below sea level, the West Antarctic ice sheet. And the reason why we're worried about this area is because the only reason there's an ice sheet here resting on the bedrock is because the ice sheet is thick enough to push its weight down onto the bedrock. If it starts to thin, it could eventually start to float, and then there would be nothing holding it in place and it could collapse very rapidly. And this is the area, if the whole area melted, that would raise sea level by around 5 meters. That wouldn't happen in 100 years, but might happen over the course of the next few centuries.
The Hadley Centre, west of London, is the UK's leading centre for climate modelling, one of the research stations that helps the United Nations Climate Panel form judgments about how serious global warming is and how we should respond to it.
Well, in order to make a prediction of climate, we first of all need to know what the emissions of greenhouse gases are. And to do that, we need what's called an emission scenario. So we need to know what the assumptions are about population, about the economics, about how energy is going to be produced, and so forth. Once we know what the emissions of carbon dioxide are due to human activity, we then need to model how that will affect the atmospheric concentrations. because carbon dioxide is not just emitted through industry and so forth. There's a natural cycle of carbon between the atmosphere, between plants and the ocean.
But carbon dioxide is by no means the only factor affecting climate change. There are many other influences which can heat or cool the Earth.
We also have small particles, rather confusingly known as aerosols, which can generally cool but can also warm climate. Then we have natural factors such as the effect of big volcanic eruptions, which tend to cool climate, or changes in the output of the sun. So before we can actually try and make a prediction or rerun what's happened in the past, we have to know what all those factors, how big all those factors are.
This is a laser cloud-based recorder. Clouds are vital to our understanding of global warming. They can both heat and cool the Earth's temperature by trapping heat, which warms us up, but they also reflect back sunlight, which cools the temperature. It all depends on how high the clouds are, how thick they are, and the composition of the water droplets inside them. Scientists at the Hadley use a powerful supercomputer to model these factors, and these models produce the predictions about global warming in this century and how that will affect things like drought and rainfall. In fact, the assumptions about clouds, particles and water vapor make at least as much difference to the predictions as does the assumption about levels of greenhouse gases in the atmosphere.
The recent IPCC report gave a range of something like a warming of 1.4 to 5.8 degrees by the end of the century. About half of that is due to uncertainty in what the emissions of greenhouse gases are going to be, and about half is due to uncertainties in the modelling.
The differences between those models are converging. Eventually, perhaps in 10 or 20 years, we'll have come out with a set of standard, reliable models to predict climate change. The other side of the uncertainty, the other reason for the uncertainty, is that we just don't know how carbon dioxide and methane levels in the atmosphere will increase in the future.
A comparison of the most recent models published by the UN Climate Panel, the work of 9 different modelling centres, give 9 different results. The temperature predictions vary by more than 4 degrees, which is very significant, and at this point the UN regards each possibility as equally likely. In other words, we don't know. Much of the media, however, ignored the lower figures entirely and focused exclusively on the more sensational end of the spectrum.
Much of the alarmist thinking behind Kyoto ignores the fact that by the middle of this century, if not sooner, developments in both technology and economics will mean that renewable energy sources, wind and solar power in particular, will begin steadily to replace fossil fuels as a major energy source. Renewables have been dropping in price by 50% per decade for the last 30 years. Even a pessimistic view would make renewables as cheap as fossil fuels by mid-century. Wind and solar power produces no carbon dioxide.
What's more, it's accepted that Kyoto will not stop global warming. It'll merely delay it by about 6 years of the century. As one recent model suggests, from a scientist who's a leading member of the UN Climate Panel, if we don't intervene at all and presume a temperature rise of 2.1 degrees by the year 2100, the difference Kyoto will make with full implementation would be to limit the rise to 1.9 degrees by the end of the century, rising to 2.1 degrees 6 years later. So the villager in Bangladesh who will have to move away from his house in 2100 because it gets flooded can now wait till 2106. A little good, but not much. The most its proponents can say for Kyoto, and fewer nations support it, is that it's only a first step. I would say it's a wrong turning. Despite all the dramatic news of disaster, the UN reports that it can find no evidence to support the idea that severe weather had worsened over the 20th century. The higher cost of severe weather is largely caused by the increase in population, with greater wealth and assets to lose, and growing numbers of people living near the sea. That's also the view of the insurance industry. Last century, sea levels rose by between 10 and 25 centimeters. Yet, did anyone notice? We adapted, but adaptation costs. Most economic estimates put the cost around $5,000 to $8,000 billion. That's a cost we pretty much have to pay whether or not we do anything about carbon dioxide emissions from now on, whether or not we implement Kyoto. We can't stop whatever warming is already underway, but if we do implement Kyoto, we could end up paying twice.
The cost of Kyoto will be somewhere between $150 and $350 billion every year from 2010 for the rest of the century. That will depress global economic growth, which includes growth in the developing world. I would say that if we really wanted to do good, we could do much better. We could solve the single biggest human problem in the world once and for all for the cost of 1 year of Kyoto. For $200 billion, we could give permanent clean drinking water and sanitation to every single human on Earth, saving 2 million lives each year and avoiding 500 million people getting severely ill every year.
This is the underlying point of my argument. We need to make sure that we do the right thing, that we don't just do something that feels good, but something that actually does good. Rather than salve the conscience of the developed world with an expensive penance, we could focus on development in the third world and make sure that the world's poor get a chance, eventually, to worry about sustainable environment every bit as much as we do.
I suppose the real point about Lomborg is, yes, things are bad, but instead of being hysterical about them, ask what's the most intelligent way of spending, where's the best way of spending your money?
I think he deserves credit for asking questions that were perfectly legitimate to ask, even if sometimes the answers were rather simple and can easily be questions can easily be ruled out. But nevertheless, they're questions that are interesting, questions that everyday people want to know the answer to.
One thing can be said about Lomborg. He's added the grit in the oyster. In other words, he's brought some real bite to the debate about the environment, which anyway, however you looked at, was becoming flabby and self-indulgent.